Thanks for joining me on Fascinating Frontiers, episode 49. It's April 6th, 2026, starting the week with the latest from space and science. Artemis II astronauts have entered the moon's sphere of influence, marking humanity's return to lunar space. The 4 astronauts of NASA's Artemis II mission entered the lunar sphere of influence early on April 6th. This sets up the first crewed lunar flyby since 1972. The mission is successfully testing the Orion spacecraft in deep space. It serves as a critical rehearsal for the Artemis III lunar landing. Houston Mission Control is actively supporting the crew during this historic flight. The flight will test the Orion spacecraft in deep space ahead of Artemis III. This marks a major step in NASA's return to the moon. Houston has been cheering on the crew reclaiming its place as Space City. I find it remarkable how these real-time connections between Earth and deep space make the whole endeavor feel so immediate. While NASA pushes forward with crewed exploration, the agency is also facing some very earthly challenges back on the ground. NASA is on the brink of its greatest achievement in decades with Artemis. At the same time, the agency is confronting proposed science budget cuts. Administrator Jared Isaacman has defended a fiscal year 2027 budget proposal. That proposal would slash the agency's funding by nearly 25%. Work on the SLS Mobile Launcher 2 has been halted. The agency is shifting its launch architecture priorities. NASA has stopped work on a second mobile launch platform for an upgraded space launch system it no longer plans to develop. The decision reflects shifting priorities in the agency's launch architecture. It raises questions about priorities in human space exploration. These budget realities show how even the most ambitious missions must navigate political and financial constraints here on Earth. Even as budgets tighten, international partners are finding new ways to work together in space. China and Europe have successfully launched an unusual collaborative space mission. The partnership marks a rare alignment between two of the world's major space powers. The collaboration represents an unusual partnership between major space powers. It highlights the evolving nature of international cooperation beyond traditional alliances. I am genuinely curious to see how this kind of cross-continental teamwork might open new doors for future exploration. Space has always had a way of bringing unlikely players together when the goals are big enough. From large-scale human missions to the quiet beauty of starbirth, let us turn our attention to what the James Webb Space Telescope is revealing. The James Webb Space Telescope has spied once-hidden features in the W51 star-forming region. It used infrared light to pierce dense clouds of gas and dust. Combined with alpha-millimeter observations, the telescopes are revealing protostars. They are also showing outflows and complex chemistry previously hidden from view. What looked like an opaque nursery is now revealing dramatic processes. These processes remain invisible to optical telescopes. The new images show the messy, energetic environment where new solar systems are taking shape. ALMA complements this by observing at millimeter wavelengths. Together, they paint a fuller picture of how stars emerge from their natal clouds. This view helps us understand the energetic chaos that eventually leads to stable planetary systems like our own. Speaking of star formation, one of our listeners recently asked a fascinating question about how protostars actually evolve. Now, here is something that blew my mind when I looked into it. Early protostars are fully convective and contract almost isothermally along the Hayashi track. If you could shrink the sun down to the size of a basketball, a typical protostar on the Hayashi track would still be roughly the volume of a small house. Yet it would contain almost the same mass. The young star is fully convective, like a boiling pot, where giant churning cells carry heat from the center all the way to the surface. Because this convection is so efficient, the star can contract while radiating energy outward. It still keeps its surface temperature almost constant. That is why it slides down the Hayashi track on the Hertzsprung-Russell diagram. The heat is carried by massive blobs of plasma rising and falling. So the interior stays well mixed and the surface can stay cool even as gravity squeezes the star smaller. Then something changes once the core grows dense and hot enough. Opacity drops and radiation takes over as the main way energy moves outward. A radiative core forms because photons can now travel through the hotter, more transparent gas. They do so without being constantly absorbed and re-emitted. On the Henyi track, the star contracts at nearly constant luminosity. Its surface heats up because the energy is now flowing through a stable radiative interior, instead of being dumped at the surface by convection. Temperatures inside these cores can reach millions of degrees. This happens on timescales of hundreds of thousands of years. Yet we still do not fully understand exactly what tips the balance between convective and radiative transport. This is especially true in stars of different masses between half a solar mass and 3 solar masses. That precise switch continues to challenge our models. The transition determines how quickly the star will eventually ignite hydrogen fusion. Then it settles onto the main sequence. Think about that for a second. The entire fate of a newborn star hinges on this subtle change in how it carries heat. It is one of those beautiful details that makes stellar evolution feel both predictable and mysterious at the same time. While we study distant star-forming regions, some very human and surprisingly practical challenges are making headlines on the Artemis II mission. The Artemis II crew has been dealing with Microsoft Outlook issues while in space. This highlights the unexpected software challenges of long-duration human spaceflight. Toilet troubles have reportedly been the biggest headache of the current lunar mission. This detail underscores the practical engineering realities of crewed deep space travel. One Mississippi State University alum is managing the Artemis II mission. Another supports its readiness. Their involvement shows how university talent contributes to major NASA programs. It is easy to focus on the grand vision of returning to the moon. But these everyday frustrations remind us that spaceflight is still fundamentally a human endeavor with all the small complications that come with it. And finally, a few quick stories from our community that show why we all keep looking up. An amateur astrophotographer captured a stunning star field at Joshua Tree. They did it with just a 10-second exposure despite cloudy conditions. A backpacker in Joshua Tree managed to photograph a phenomenal starry sky. The amateur astrophotographer shared the result for the community to enjoy. Another observer used a Celestron 8 SE telescope to image a retired geostationary satellite. The object appeared as a stationary dot against streaking background stars. The satellite shows slight declination drift. This is consistent with an inclined geosynchronous orbit. It is always inspiring to see what dedicated amateurs can achieve with modest equipment and clear skies, or even cloudy ones. Before we go, keep an eye on how the Artemis II crew handles the remainder of their lunar flyby as they prepare for the return journey to Earth. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.
Drifting softly through the black, a million stars behind our back. The void hums low.